The last thing we need to cover before we start reactions is talking about substitution on alkanes and alkenes. So if I draw this structure right here and add a propyl group, when we talk about substitution, we use degrees. Primary, secondary, tertiary, and sometimes quaternary. So if we look here, you want to look at the carbon and see how many carbons it's attached to. So this carbon at the end here is only attached to one other carbon. So this is a primary not carbocation, a primary carbon. This carbon right here is attached to two other carbons here and here. So this one is secondary. And this carbon right here is attached to three other carbons, so it is tertiary. Sometimes we have quaternary carbons, not very often, but this right here would be a quaternary carbon. And if it's not attached to any other carbon, it's a methyl group. So we have a methyl. Okay, so if we look, if I have this drawn, CH3CH2Br, this would be called a primary alkyl halide. Or if I have a carbon attached to three other carbons and then attached to an OH, this would be a tertiary alcohol. Now, there's another kind of substitution when we look at alkenes. If I have an alkene like this, where the double bond is only attached to one other carbon, this is called monosubstituted. If I have my alkene attached to two other carbons, like this or like this, then this is disubstituted. And correspondingly, if I have my double bond attached to three other carbons, this is trisubstituted. And of course, one more. If I have something like this, this is tetrasubstituted. Generally, the more substituted, the more stable. The last thing we need to cover is carbocation stability. So if we look at a carbocation, I'm just going to draw this methyl carbocation. We have three H's attached to the carbon, so the carbon has a plus charge. Now, if I want a primary carbocation, I would add another carbon to this carbon. And so I'll have my two H's here. And then add a methyl group. So this is a primary carbocation. A secondary carbocation will have two methyl groups attached to the carbon. And still an H. And a tertiary, of course, would have three. Now, the order of stability is this. This is much less stable than primary, which is less stable than secondary, which is less stable than tertiary. There's a reason for this. This is called hyperconjugation. It's a way for this plus charge to be spread through these carbons. Doesn't really matter, just want you to realize that there's a reason why a tertiary is more stable than a secondary, than a primary, than a methyl. So why is this important? Well, if we have a reaction that can possibly go through this carbocation, the tertiary carbocation, instead of, say, rearranged a little bit, let's put CH3 here, and then H here, and then make it into a primary carbocation. So my red pen will indicate the tertiary carbocation. And my blue pen will indicate the primary carbocation. Reactions aren't smart, or maybe they are. They will always take the path that is lower in energy. So it's important to know which carbocation is more stable than another to be able to predict the product of the reaction. So with the preliminaries all done, we'll go into nomenclature, which is naming alkenes, and then we'll look at the reactions of the alkenes.